This presentation will be about templates on the web and how templates can learn from the experiences XML already has with templating. Templates on the web are everywhere. Everything is built out of templates. So for example, in this screen on Google, you have an autocomplete, and there's already a conditional template, and for each template, and even a tokenizing template. So the whole drop-down menu is inside a conditional, and it shows the autocomplete keywords inside of for each template, and the highlighted parts are created using, for example, an analyze string template. Or when you're on Twitter and you're composing a tweet, there's a countdown timer for the amount of characters that you still have left for your tweet. It's right here. It says there's 2 characters left. And that is also a template. Usually, templates are implemented in different ways. The usual way, using jQuery, is about patching the HTML template. So if you already have an existing HTML page, you need to find where the part of the pages you want to update. So in this example, that's what the first part is about. Or the second part is about. You need to find the element with ID tweet limit, and you need to enter the amount of characters left. So every time someone types inside the text area, an event is fired, and the amount of characters from the text area is requested using event.target.value.length, and it is subtracted from the limit of the tweet, which is 140 characters. So in this example, you have the Gmail sidebar, and it highlights the amount of unread emails. This is also a template. Using jQuery, first you will have to find an event that triggers the change of the data. In this example, when you load new data from the server, a JSON file, for example, you need to check if this file is about the amount of emails. Then you find the element in the sidebar, and you update the contents accordingly. So if you have unread emails, you have one template. Inside a strong element, you show the amount of unread emails within parentheses. Or you just show the name of the inbox, which is inbox for the default template. All this clutter in your code about mixing concerns about when data changes and what parts of the HTML to update and what the exact template is, people move away from jQuery because it's cumbersome to maintain the code. And a new couple of JavaScript MVC frameworks are replacing jQuery in this sense. A couple of examples are Ember.js, Angular, Knockout, and also notably Polymer, which is using web components. So, differing from jQuery, they do a couple of interesting things. One thing they do is they don't actually listen to changes of form inputs. They bind form inputs to the data model. And templates only listen to changes to the data model, so they are loosely coupled. And instead of patching the HTML and finding the HTML that already is there over and over again, you declare the templates of what is going to change in your original template of the sidebar for Gmail, for example, or the composing tweet screen. Also, they handle a lot of clutter as well. For example, if one value in your model changes, without using an MVC model with automatic recalculation, the value that changes needs to notify all dependent other values. So if there's a value C that is consisting of A with B, the values A and B must notify C when they are changed. All these MVC frameworks handle these dependency chains. And if a value is calculated and depends on multiple others, they will automatically be updated when needed. And not only the values that are available in the model are automatically recalculated, also the templates are updated as fast as possible and as partial as possible. So if you remove one item from a list, they try not to re-render the whole list, but just remove one item from the rendering. And for those who don't know what form bindings are, I have an example over here. Usually you would have an input, HTML input, and you would have an ID on that and add an event listener for that. When the value for the range changes, you do some calculations to update the HTML. In this example, there are no event listeners. They only refer, the input only refers to the model. In this example, a variable called beer bottles. And another template, which isn't directly coupled to the input, renders a certain amount of beer bottles. So this is an implementation of this template. This is the range input, which is barely visible when you use it on black. So you can actually change the model here, and the template will recalculate automatically. And every time, only one character is added instead of re-rendering the whole list. So everyone, or most of you, will recognize all these features that are already in existing web standards, like XForms, XSLT, and XPath for that matter. XSLT provides powerful templates, and XForms handle all the input bindings to the model, and also handles updating the model. And if you were to combine those two, XSLT, all the flexible templates, with the editing of the model using XForms, you get basically what these new frameworks are trying to offer. However, in practice, these template engines, these JavaScript MVC frameworks, cannot actually handle all the things that you would like them to. For example, only the most simple template instructions are available to you. And the query engines that are used are, well, basic in some examples aren't even query engines. You can only look up one key of one object. So in practice, you still need to write a lot of JavaScript. So on these websites, they advertise that you can create a web shop like this. So if you have some search results for your web shop, you can render for each template, and for every search result, a div is created with a product. But actually, you've already seen most of the template language already, because they are only in Mustache, which is the most often used template language. You only have for each, which is visible in the first instruction. And you have a text template, and you have an if-not template. So this is what in XSLT this would look like. Just an XSL for each and a value of, although with a lot of less characters. They also offer if-not template. And the reason they offer if-not templates is not so much to offer some kind of word conditional template. It's mainly used for when a for each doesn't show any results at all. For example, if you have for each for the emails in your inbox, you would add one of those when your inbox is empty. And in essence, your template language is only as powerful as your query language is. Because if you can only target a couple of things from your data model, you can only create very simple web pages or web applications. And Mustache queries only allow you to select properties from the one object that is focused. So for example, if you have a person object that is focused, you can only access the properties of a person, for example, name. You cannot select any subparts like address / street or something like that. Implementations of the Mustache template actually add some more functionality, but only barely. You can access the whole tree using the dot selectors, which is like / in XPath. And you can access indexes from a list, but only when they are statically known. So you can only access like the first or the second, but not the end of a list. So as you can see, if you need to write a web application using these templates, there are so much more you could have done when you would use XSLT. There is grouping in XSLT, sorting, which isn't available in Mustache either. Sorting that uses Unicode, which is, of course, if you have some letter that has a trema or umlaut on it, you don't want it to end up on the end of the list. And you have templates like analyze string, where you can process parts of strings, which is used often as well. For example, in the Google example for autocomplete, for highlighting the parts that you have already typed in the search box, or in the Twitter compose text area, where usernames of Twitter are highlighted in blue, or hyperlinks that are recognized are highlighted as well. And in the same way, you would miss the flexibility of XPath, because you can only list all the emails in your inbox, because that's the only array that is visible. You cannot filter it to show only the unread emails, for example. You would need filter expressions for those. And XPath has a lot of things, XPath 2 especially, has a lot of things that happen on the web as well, such as date formatting, time formatting, and date calculations. Map functions as well, and of course, Unicode support is really, really nice to have. If you're a web developer, you might not think about it as much as implementers do, but I will show you an example why it's really good for template engines to take care of this. So for example, Unicode's regular expressions are not part of JavaScript, but they are and have been for a long time part of XPath. So this is someone from Finland, and she couldn't register for some web shop because she didn't have a valid last name. And this is something that Unicode regular expressions fix. And the same goes for having a maximum length on your tweet, for example. If you have an accent on an E, for example, that could count as a separate character, while in practice it really isn't. And this is another example. You might think, why would we need to do arithmetic with dates, subtracting one date from another? But in the Twitter timeline, this already happens. So here you see this tweet is 10 hours ago. And 10 hours ago, that is calculated by subtracting the date of the time, date of the tweet, from the current date time. So then you get 10 hours. So if XML, the XML platform is so powerful, and the templates have so much possibilities, and XPath is really awesome, why don't people use it? Well, mostly because XPath is designed to traverse XML structures only. It doesn't traverse JSON, for example. And that is something that Mustache is fully designed for example. And that's why Mustache became so popular. Because Mustache is a template engine that is designed to be used for native objects and native arrays of whatever programming language. So there are Mustache implementations for Python, JavaScript, or whatever language. And you can feed them objects from that language and create HTML from that. Also, the syntax of XSLT is fully designed for XML and for people who know XML and appreciate namespaces. So while I might like XSLT and XPath a lot, many people don't see the use of namespaces for their particular web application. And also, it takes a lot of time to program a web application using XML. If you compare creating a regular JavaScript object to creating a bunch of HTML elements that are nested, that takes like 10 or 20 times the code. And maybe that all could have been overcome by a couple of helper functions that create the XML for you from native objects. But in the browser, these extensible standards are really not so extensible at all. They're set in stone. If there's one feature from these standards missing in the browser, and it's essential to your web application, you cannot use the standard at all. And this applies to both XPath and XSLT. And I guess XForms does, as a native browser technique, doesn't really apply anymore. But the same goes there. How could you implement your own datetime picker for the browser's XForms implementation? So in the browser, if you would want to use XSLT for your templates, and you would need to do some grouping. For example, if you have a weblog and you need to group all your posts by year and then by month, you need for each group. But you cannot just add for each group as a polyfill. Like many new browser features have a JavaScript equivalent that you can include in your page and make the new feature work in older browsers. But even in the latest browsers, there's no way to extend XPath and XSLT in this way. And perhaps if the XSLT engine was based on web components, you could have extended existing template constructors and actually implement XSLT2 when only XSLT1 is supported. But even for basic examples in XPath, you cannot, you would expect this to work in a browser, but it doesn't. You can not use variables using the DOM XPath evaluator, something that is really basic and would probably be only a couple of minutes work to add to the browser. But you can do this. And of course, you can, in this example, if this is an ID, you can patch the query and add the string right into the query string. But for comparing node sets, this of course isn't possible. And for example, if you want to do a format number and you would rely on the XPath, if you would rely on the XPath query engine in the browser, you cannot actually use format number in the browser because this function is limited to only be used in XSLT. So within an XPath evaluator, this function is not available. So why not add the function yourself? Well, you can't. Adding custom functions to the XPath language is not possible in the browser. You're set with like 40 or so basic functions, and that's it. Well, I'm starting to see why people don't or wouldn't switch to XPath for their template languages. So if you would have a Mustache template implementation, you wouldn't switch to using XPath for queries. So the web is a place where really the most diverse kinds of templates are found, and most of them are interactive as well. But the existing template languages they use are really underpowered for this task. And there's no way that XSLT and XPath from the browser will be of any help to bridge this gap and add some more power to the web applications. Also, people are used to add like a big red button right inside their HTML. And for XSLT, this is not possible. You cannot embed XSLT right in your HTML page, partly because of the syntax, of course. But even if you were to use XHTML syntax with the according media type, you cannot use the, I'm not sure what they're called again, but you cannot use the XSLT templates that don't have a style sheet element as a root element, but some other element like HTML. And even if we were to solve all these problems and we were to add APIs for adding functions and implementing variables, etc., the XSLT syntax is still too much apart from what the web developers come up with when they do it by themselves. The XSLT examples are so much more typing than the Mustache templates. People just wouldn't like it. So I really liked XSLT. It's even the reason I met a lot of people on the web, like Anna van Kester in 2003. The reason I met him was actually that we were one of the few people on the web who were interested of using XSLT in the web. But when actually using it, I really wanted to extend the language. So that's what I started to do with Frameless. Frameless is a project I've been working on for the last 2 years. And I was hoping to bring the power of XSLT and XPath to the browser and to be able to use it in web applications. And how I did it is I tried to reimagine what XSLT would look like with all the power and all the instructions of XSLT, but using HTML syntax. And also combining it with XForms, because XForms were meant to be an improvement of HTML forms, but didn't really become popular and weren't implemented in browsers. But I mean, XForms is still appealing to a lot of people, and what can be done to bring the power of XForms to the web even still? So I also made sure that all the templates could be used straight inside of HTML. So there would be there would be very little time before you could get started. You would only include one library, one JavaScript library, and you could already copy and paste templates, example templates inside your web page, and they would work. Also, to prevent the same mistakes that the browsers made by not making XML standards actually extensible, we have lots of API to influence the workings of the template engine and the query language. Also, when you would switch to Frameless or HTML templates as a JavaScript programmer, which you are when you work as a web developer, there are several functions that you expect to be there. We also made sure that everything that people would know from JavaScript is available in XPath as well. And something that isn't actually in XSLT but would be really powerful is to combine XForms, where you could edit the model and the rendering would update accordingly. So for example, you could implement Google Maps very easily. Stephen Pemberton did this by just using an image that is parameterized by some variables from a model, and it would show the Google satellite view for those coordinates. This live rendering and live updating of XSLT templates, that's what we implemented. So when one part of the model changes, you wouldn't have to re-render the whole applications. And of course, the form bindings like found in XForms. So to do that, there was a lot of work to be done because we couldn't rely on the browser's XPath implementations. We couldn't use the current XSLT engine. So we had to implement those from scratch entirely using JavaScript. So we implemented XSLT2 and XPath2 in JavaScript. We added extensive APIs for those. And we also developed some templates that could be used using just HTML elements. So this example again, with a tweet where you compose a tweet, that's a form input that is bound to a data model where the tweet is stored. And you react on what is typed inside the form. You count down the characters that are still left in your tweet, and also you disable when the tweet is disable the button when the tweet is empty or it is over the limit. Using HTML templates or these HTML templates, that's very simple. The text area, and like all other form elements, have a new attribute, the ref attribute that you might know from XForms. That refers to the model, and you have an inline template that works like Mustache templates, and also is similar to how the new XSLT tree text templates work. You just put like a value of instruction within curly braces. And this example already works, and it's below here. So this is all you need to type, all the programming you need to do to implement the Twitter compose screen. It's really very simple, and there's nothing you need to do to actually make this update the screen when you type. And this is another example where you have a registration form, and you want to react to that as well, because there are certain validations you want to do. And besides that, the validation can be done in a separate step. You might want to show particular error messages for particular conditions. So apart from maybe a regular expression you would want to use for the passwords validation, you can also show an error message like here. If your password is XMLPrague and the minimum is 10, it's actually too short. But if you add a couple of characters, the message will disappear. And the only thing you will need to write is an if attribute with a query that refers to your model. And this is the kind of power that was imagined for XForms and also was imagined for XSLT, but in a lesser extent because it wasn't meant to be live. But the combination of this makes writing web applications really, really easy and very less error prone. This is an example I don't have a live inline demo for, but it's mainly here to show the syntax. What you would normally write is an XSL form for each group. Oh, by the way, what we're doing here is if you have a weblog and you want to show, for example, in the sidebar, the categories of blog posts you have, you want to list all the blog post tags, but you don't want to show any duplicates. So you throw out the duplicates, and you only show each unique tag that is attached to the blog post. So in this example, we loop over all the tags found in all the blog posts, and we group by the value of the tag itself, which is the dot or the period character, and refers to the current tag. And for each, by using group by, we throw out all the duplicates, and we show a template for the first tag that was encountered. By the way, using the sort attribute, we also sort by default on the current value of for each. You could add multiple sort attributes, which are like the new responsive images. You could use, for example, sort1 is first name, sort-2 is last name. But in this example, we show all the tags, and we show a list item showing there are 17 blog posts in the category Unicode. But coming from Mustache, this is still very little code, and it can be embedded right into HTML. The for each element can be implemented using web components, for example, which perhaps makes it even more extensible. And yeah, well, this would be like 100 lines of code using JavaScript. So when I started dog fooding and writing applications using this template language myself, there are all these functions that I know from JavaScript that have no equivalent in XPath. For example, there is this string split function, which there kind of is an equivalent for, But in JavaScript, you can use a string to split, for example, by comma to create a comma-separated list. But XPath currently only has tokenize, I believe, which takes a regular expression as an argument. Same goes, reversing a string is possible in JavaScript, but not in XPath. Replace is also one that doesn't exist without regular expressions. And string repeat is something that would be nice as well. Same as trim, for example, which removes all leading and trailing white space, but leaves the white space between words intact, which normalized string doesn't. Also, there's this promise that if you start using XPath, there are these value types for dates, times, date times, durations, and you would be able to create templates for that. For example, you could implement a calendar very easily. But in fact, that is not so easy at all, because for a lot of information, only the format date instruction function is available, where you would need to distill a number from to, for example, generate SVG offsets. So format duration is one very obvious example that is missing from the spec. You have format date, but if you subtract two dates, you cannot format it. And durations by themselves also occur. For example, if you're playing a YouTube video, there's a duration for the amount of minutes and seconds that the video has been going on. So here there's a 2-minute and 2-second duration, which you cannot format currently using XPath. But I mean, video and audio occurs widely on the web, so those functions should be added as well. And using this declarative syntax, there is so much interactivity that you can implement using only the code to create like a static equivalent. In this example, I have described a SVG clock, which consists of 3 hour hands, which are the path elements, that are offset from the center of the image, and that point outwards. And each hour hand or second hand has a certain angle under which it is rendered. And the angle is calculated by using the actual current time of the system. And if the current time of the system were to be live, then every second, for example, the template would be updated and the hour hands would move. So, for example, this is the current date time, and we take the hours from that, and based on that, we turn the hour hand to the correct position. For the second hand, you need to mind that the seconds are returned in a decimal value, and 1 second can actually be 1.99 seconds. So you would need to use the round it to a whole second, or floor it, to be precise. Well, using these interactive templates, basically all web applications on the web can be developed using so much less code. And if you have XPath selectors, you can basically render all information from your data model that has been loaded from the server, for example, or has been generated by JavaScript. And you can create a live rendering for it. So I always liked writing XSLT, but I really love writing these live interactive templates. Thank you.
We have few time for questions, so please raise your hand if you have questions. Oh, okay.
How complex can you make your interactions? Because what you've just seen is basically very light surface functions. And typically, when you're starting to do something really complex, you've got a lot of background machinery interacting functions, or in XSLT, lots of templates working as well.
Mm-hmm. Yeah, these examples don't show that, but we're actually implementing the whole of XSLT as a live template engine. So I think the best way to see this, if you would see the template engine as rendering, for example, a docbook document as HTML. If you would have a web viewer for docbook documents, you would actually see the whole document in HTML. Now, if you could put a caret in it and edit the text and press enter, there would be template matches. For example, if you would have a template that says, this is a paragraph, this is the template for a paragraph, and there would be a second template that says, I'm a template for a paragraph that contains line breaks. If you were to press Shift-Enter and insert a line break, we actually have a template switching mechanism that recognizes that the template match with the line break has a higher priority, and it updates the template that has been rendered to the template override. And we'll still have to see how this would work with web components and HTML templates. But yeah, this is basically everything you would want to do within XSLT, and all the trickle-down values you would have there. Oh, for example, I did this demo jam a couple of years ago, and I showed animating graph, a 3D graph of animating values. There was this rippling plane, and the position of the planes were the position of the graph was calculated based on the current time, and there were all kinds of formulas involved, but only the time changed, and the whole 3D graph was updated atomically. Only the style attributes were updated, because somewhere up the dependency tree, the variable with the current day time changed. So everything is re-rendered and partially recalculated. And so basically, because there's a dependency graph, you can make it as complex as you want, and as long as you don't add any loops using JavaScript APIs, you should be fine.
Okay, thank you. Oh, one last question. Yeah.
Yeah, thank you for your talk. I feel like your comparison to Mustache is a bit unfair, because at least that's the template language I know is like the most basic one, and all the examples you showed, and I think, and you compared it to Mustache and said that it's much shorter, but if I compare it to AngularJS or something like that, I don't really see that much benefit. I think it would be like the same length. Of course, it would look a little bit different, but I don't really see, so what's really the incentive for a JavaScript developer to switch to Frameless or any other XSLT forms, XSLT-based templating language?
Okay, yeah, well, there are a couple of, you're very right that Angular expressions are more powerful than Mustache queries. Because Angular queries have like a map operator or the slash operator from XPath. You can pipe values after each other using your own JavaScript functions. But the great thing about using XPath as a notation is you don't have to move as much logic to JavaScript as you would using jQuery, using Angular. And the great thing about that is that you can statically determine the dependency chain without recording what the JavaScript actually does in the functions that implement sorting or currency formatting or whatever. You can do much more analysis and automatic optimizations when you can inspect what the queries do. And besides, the template features from XLT are much more extensive than from Angular. I mean, of course, you could do a lot using for each, but there's no default grouping in Angular, I think.
Okay, thank you.
Yeah.
Sorry. Thank you. So thank you again, Robert, for this presentation. Yes?
Oh, not he.
Oh, sorry. Good. Oh, again you.
Yeah, just a cheeky question. How did you get your download so small compared to Saxon C?
Yeah, well, we did a couple of things for that. One of the things is that we actually wrote JavaScript and not Java. So we could directly influence the download size. And also one part why Saxon is is larger than Frameless is they have Unicode tables they download. I think they do that optionally now, but that also increases the size dramatically. But we are specialized in writing JavaScript that is very small. And also we use Google Closure Compiler, which we use to make our JavaScript statically typed. So the compiler can infer a lot of information about our code and can inline functions, can remove dead code, and much more optimizations that aren't possible even for regular JavaScript libraries like Angular or Ember.js. They would benefit from that as well tremendously.
Okay, I think we're done. Thank you very much, Robert. And yes.